Today we start our unit on logarithms, okay? Now, some of you have told me in the last couple days that you wish we'd done logarithms already because you've been working on logarithms in physics or chemistry or something like that, okay? So, we're going to do them now. How about that? Because now is when they come in our curriculum, okay? So, but I want to go back to stuff that you know and go from there. Fair enough? So, shown to the left, right over here, is the exponential function y equals 2 to the x power. For what value of x is the function equal to 20? Is that something we could read this graph and figure out? Where's the function equal to 20? Right there, right? Is that something we can know exactly where that is? By looking at the graph, we can know exactly where it is? No. It would be a guess, right? Okay? In other words, what exponent can you use on a base of 2 to get the answer to 20? Or, at the very basicness, solve this equation. 2 to the x power equals 20. Okay? While we may not know how to solve this equation yet, we can approximate the solution in several different ways. So I want to pull on what you know to get us where we need to be. Fair enough? So let's figure out how we can approximate the solution. We're going to do 3 different ways. The first way is usually your favorite. You do it on a lot of stuff, right? Guess. You guess. Now, like the more appropriate mathematical term is trial and error. But all you're doing is guessing, aren't you? Okay? Because we're not looking at our calculator at this point. We're just thinking about it. Okay? Between what 2 whole numbers does the solution fall? 2 to what power equals 20? What would x have to be? Between what 2 whole numbers does the solution fall? Why would you say 4 and 5? Because 2 to the 4th is 16, and 2 to the 5th is 32. And isn't 20 in between 16 and 32? Yeah. So, which one of these numbers is it closer to? Is it closer to 4 or is it closer to 5? Closer to 4. Why would you say it's closer to 4? Yeah. 20 is closer to 16 than it is to 32, isn't it? Okay? Very good thinking. So, like how much closer? Like, because we're guessing here, right? This is trial and error. Do you think it's 4.1? Do you think it's 4.2? Do you think it's 4.3? Do you think it's 4.7? What do you think?
4.36.
So I have 4.36. I have 4.25. We're guessing, aren't we? Now, you guys are forgetting to read the instructions because the instructions say we're rounding to the nearest tenth. What does that mean? 1 decimal place, right? So 4.3, 4.2. Anybody else have another guess? Or you want to go with these 2? With these 2? Okay? So that's our guess so far. Now let's use a table in our calculator because up to now we haven't touched our calculator, have we? Let's use a table in our calculator to approximate the solution to the nearest what? 100th. How many decimal places is 100th? Excellent. 2. Okay. So in our calculator, we need a graph. So I need to make a new document that is a graph. What am I putting into my y equals? My function line. Oops. What am I going to put in there? Yeah, 2 raised to the x power. That's what I need to see, isn't it? I'm looking at the table, so I'm going to press Control T. Except I have a problem. How's my table counting? By ones. What kind of answer do I need? I need to 100th. So I need to go where? Where do I need to go? Menu. Table. Very good. Edit table settings, number 5. Where do I want my table to start? I want this to start, this is an X value, isn't it? So I want my table to start at 4. Exactly right. Tab. How do I want my table to step? How do I want it to count? I've got to get an answer to the nearest hundredth, so that means I want my table to count by 0.01. Very good. Enter. All right, now I'm here. What am I looking for? I'm looking for my Y value to be 20. Oh. Well, it's not 20. It's close, right? So I need to copy my table down here in this blank. I want to give myself a good view of what's going on, so I probably want at least 4 values. 1, 2, 3, 4. What do I want in the 2 values in the center of my table? What X values in the center of my table? 4.32 and 4.33. Why would I want those 2 values in the center of my table? Yeah, in between there somewhere is when exactly 20 happens, doesn't it? So let me go ahead and put 4.31 and 4.34 in as well. So 8353 and 19.9733 and 20.1122 and 20.2521. Now, it still wants us to make a guess. Approximate the solution to the nearest hundredth. Which one of these is the one that's nearest to 20? Why is 4.32 the one that's nearest to 20? I mean, this is only 0.1. Why isn't this one nearest? Yeah, this is only 0.03 away. Isn't that closer? Yeah. Okay. All right, last way that we want to check this out is using a graph. It says use a graph to solve the equation. How accurate is this method? Well, I've got my calculator already. I've already got the graph over here. I want to get rid of the table so I can see what's going on. So I just press Control-T to get rid of the table. How in the world am I going to use a graph to solve this? What was the equation I'm trying to solve again? 2x equals 20. Well, I've got the 2x in there. What am I missing? Yeah, the 20. So I'm going to hit Tab so I can get another entry line, and I'm going to just hit 20. Now, it didn't change my graph at all. Why? Yeah, I can't see it. The window is not the right size, right? The line that's y equals 20 goes horizontally, but it's like up here somewhere where I can't see it. So what do I need to do? I need to change my window. Menu, Window, which is number 4. I need to change my window settings, which is number 1. Do I care about the x values, or are they okay? They're probably okay, right? Do I care about my y values, or are they okay? Well, my y max is wrong. What does my y max need to be? Well, it needs to be at least 20, but we want to be able to see it, so let's make it 25. You okay with that? And then when I press Enter, look what I can see now. I can see that y equals 20. I don't know why it looks clear on the screen. That's kind of strange. But you can see yours okay, right? Okay. What am I looking for? If I'm trying to figure out where this exponential function and this horizontal line are the same, I'm looking for their intersection. I'm looking for that point right there. So I just say menu. I want to analyze my graph, which is number 6. What am I looking for again? Intersection. I've got to move this dotted line. Look what it says. The lower bound. So it's saying move this line to the left. And click that middle button. Then now it says upper bound. So move it to the right. And click that middle button. And when you do, look what showed up. Sketch the graph screen. Well, I've got my x and y axis, and then I've got this zhunk, and then I've got this zhunk. And this point right here is 4.32, 20. Guys, how much more accurate was that than this one? It wasn't. One of the only places that we can say accurate enough to 2 decimal places is money, isn't it? Everywhere else, we want more decimal places to make sure that we're more accurate. But so far, all we've been able to do is go to the 100th. That's not enough for us, is it? We got to know a better way. Okay? Any questions about what we've done so far? What have we done so far? We've shown different ways that we know in our brain that might work, but we need a better way. Okay? So look down here. Is there a way to solve 2x or 2 to the x power equals 20 algebraically? Well, if we're studying about it in algebra, the answer is probably yes. Okay? But again, I don't want to just give you the answer. I want you to get there yourself. Okay? So work with me for just a second here. We need a way to undo exponents like we undo this other stuff. For example, if we're adding 4, like, for instance, n plus 4 equals a, how do we solve for n? We subtract 4 on both sides to get a minus 4. And the action that we did to undo was by subtracting 4. What if I ask you to multiply by 3? For instance, 3n equals a. How do I solve for n? Yeah, I divide both sides by 3 to get a over 3. What action did I take to undo the multiply by 3? Divide by 3. Uh-oh. There's no operation here. I got to figure out the operation. What's happening here? Yeah, I'm squaring. How do I solve for n? Very good. I square root. Now I'm gonna pick on you here for just a second, because when we actually worked on this, we worked on this for a while. Okay? And I'm afraid you're gonna get it wrong. I'm not gonna make fun of you if you get it wrong. I just need you to fix it. Okay? When I take the square root of both sides, what does n equal? That's so close. What am I missing? Plus or minus. Remember that? Yeah? Okay. What action did I use to undo my squaring? Yeah, square root. So now look what our last operation is. It's an exponent. It says 2 to the n equals a. What kind of action do you think that we're going to take to undo an exponent? Here's a hint. Look at the title of the worksheet. We're going to take a logarithm. This is what it looks like. On purpose, I wrote that 2, little baby 2, and wrote it lower than the rest. If we were in computer class, what would that be called? What? Subscript, right? Isn't that a subscript? That's what I want you to think of when you're writing that. It needs to be lower and it needs to be smaller. Okay? So the way to undo exponents is to use what? I would ask you to please not turn over your worksheet quite yet. We're still on this side. Fair enough? Okay. Again, it's something I want you to figure out and not just be handed to you in a silver spoon. I am fresh out of silver spoons today. Okay? How are these two actions related? Adding and subtracting. How are these two actions or operations related? How are these two related? It's one word. What do you think? We did a whole unit on it in the middle of the year. Now earlier they said, oh, they're opposites. Well, I know what they're thinking, and while they are on the right track, in algebra, in math, we use the word opposite to mean a different sign, right? 5 and -5 are opposites, right? Let's see, what else did they say earlier? Oh, they said reciprocal, right? But really, a reciprocal is when we take a fraction and flip it over, right? Is that what's happening here? Not exactly. So what word are we thinking of? How are these operations related? They are inverses. That's absolutely right. Okay? They are inverses. So if these are inverses, and these are inverses, and these are inverses, guess what? Oh my gosh, these are inverses. Guys, that's a really big deal. Okay? Maybe not for today, but that's something I need you to store in your brain that we can pull out in the next couple days. Okay? The fact that exponents and logarithms are inverses. Because what does that mean about these two actions? It means they're really closely related, aren't they? Adding and subtracting are closely related, aren't they? Multiplying and dividing are closely related. So is squaring and square rooting. That means exponents and logarithms are going to be closely related as well. Okay? Now turn your paper over. Because guess what it talks about at the top of the next page? What does the graph of a logarithmic function look like? Well, what graph is this? Yeah, that's an exponential function, what we just did last unit, right? But we know that exponential and logarithmic functions are, inverses. If we know that they're inverses, how can we generate the logarithmic graph if we have the exponential graph and table? How do we find inverses? Very good. Switch X and Y. Well, like I said, we have a table for exponents, so how do we find the logarithmic table? Switch X and Y. Do it. Now that you've switched X and Y, how can I find the graph? Yeah, can't I just plot these points? Yeah, do it. Okay, let's see. Here's 0, 0. So if I go a fourth, then I've got to go down 2. Here's about half. I got to go down 1. Go over 1 and up and down 0. Over 2, up 1. Over 4, up 2, and over 8, up 1, 2, 3, 4. Now, this is what I saw earlier. I saw somebody do that. Is that right? Am I playing dot to dot, or am I graphing a function? Graphing a function, right? So here's the interesting part. I know that goes that way, right? What does this one do? Does it go like this? Over here? Is it going to cross the y-axis at all? Because this one, does it cross the x-axis? No, not at all, right? We know of inverse functions that'll happen. So it just kind of goes as closer and closer to the y-axis as we can get it. Do you remember how to know for sure if a graph is an inverse of another graph? It reflects across the line. I know, you're showing me with your hands. That's how I know you know. It's okay. It reflects across the line y equals x. If I folded my paper on this dotted line that I just graphed, would these two things be right on top of each other? Yes. Yes, they would. Okay? Any questions so far? All right. So, we've had already several big deals of the day. We've had the fact that we don't want to guess and check. We don't want to have to use a table or a graph to solve an equation like this. We want to use logarithms. Then we said we've got to remember that exponential and logarithmic functions are inverses of each other. But here is kind of pretty much the really, really, really big deal of the day, is this section right here. Okay? This is the big deal of the day. The definition of a logarithm. This right here is exponential form. Would you agree that that's a fair statement? Because it's got an exponent in it, a base, and an answer, right? This is exponential form. I have to make sure you understand that you can go back and forth from exponential to logarithmic form. So using exponential form, I want to show you what goes where in logarithmic form. Okay? What is this b called right here? What's it called? What's the name of it? Yeah, it's a base, right? Well, it goes right here. Guess what that's called? Yeah, it's called a base. It's called a base right here, and it's called a base right here. Oh my gosh, what a coincidence. This A goes right here. You know what it's called? It's called an argument. Why? No idea. None. Maybe they needed a word that started with an A and everybody else wanted to use the bad one, so somebody just came up with an argument. Like they fought about it, so they called it an argument. I don't know. I totally made that up. I don't have any idea why it's called an argument. Okay? But it's the answer over here. It's the argument right here. Okay? What's this called? Exponent. Guess where it goes? And guess what it's called over here? Which is weird to me because that's not really an exponent, is it? Okay? But maybe that's not called an exponent. Maybe we're filling in that word exponent right here so we know where the exponent goes. Is that fair enough? Okay? These two questions are super, super important. Okay? This is our big deal of the day, the definition of a logarithm, and these two are important. In fact, this second one, is probably going to show up on a test. Just going to tell you from the very beginning of the unit, that question is probably going to show up on your test. Okay? I need you to know how to read this, statement. I read this statement, log base b of a equals x. But that's not the only way you can read it. We're writing down this way because that's how you're going to hear me say it. That's how I was taught. That's how I say it. But it is not wrong to say log of a base b equals x. You see the difference? It's like base b and of a can switch places, and that's okay. Fair enough? So, you ready for the question that's going to show up on your test? Have you figured it out yet? Why do we use logarithms? We started this whole day today by trying to solve this equation. Why don't I know how to solve this equation? Yeah, where is my variable? In the exponent. If I write it in logarithmic form, where is my variable? It's over here, right? So why would we use logarithms? To get the variable, what? Out of the exponent. Very good. To get the variable out of the exponent. The problems on the bottom of that page, A through N, are your homework. Okay? Those are your homework. I would like to give you some sample problems before I let you go on your homework. Okay? This is exponential form, this is logarithmic form. Can you write these exponential form problems into logarithmic form? What's this called again? A base. So I'm going to write log base 5 of what? Of 25 equals 2. And guess what? That's it. You just have to be able to go from exponential form to logarithmic form today. What about this one? 3 to the 4th power equals 81. Guys, wait a second. Is that a true statement? Well, go back up here. Is that a true statement? Is 5 squared equal 25? Yeah. Is 3 to the 4th power equal 81? Yes. Okay? Write it for me in logarithmic form. Log base 3 of 81 equals 4. So I had to give you some tricky ones, because I didn't want them just to show up on the homework. Am I asking you to solve this? No. All I'm asking you to do is rewrite it. So rewrite it for me. Log base 3 of x equals 0. Yes? Last one. Log base 6 of 36 equals x. Now, for argument's sake, is this something you could solve? Do you know what 3 to the 0 power is? Because you know what anything to the 0 power is, right? We know it's 1. Could you solve this one? Yeah, just in your brain you know what x is, don't you? 6 to what power equals 36? Yeah, 2. Can you go backwards? Can you start over here and go to exponential form? Do it. What's the base? So it's the base over here. 4 squared. Is that true? Oh, good. This one's a tricky one, though. I gave it to you on purpose, because what if I got it wrong and wrote 2 to the 4th power equals 16? Is that still right? 2 to the 4th power? Yeah, it's 16, isn't it? So you just got to be careful. Okay? Rewrite this one for me. Base 6 to the 3rd power equals 216. Is that right? Is 6 to the 3rd power 216? Yeah, absolutely. I did have to throw you a curveball, didn't I? I had to put a fraction in there. It doesn't mean I'm mad at you. It means I want you to know how to do it. What's the base? 5 to the negative 2 power equals 1 over 25. And then last but not least, I have 2 more to show you, because I don't want you to be tricked. Rewrite this one for me. Huh? You think there's a problem with this? Why? There's no base. Rewrite it as if there was a base. We'll just like put a line. Something to the third power equals 1,000. Is there a base? Is there anything that you know of that to the third power equals 1,000? 10. Well, why the heck did they not write 10 right there? And by they, I mean me. I wrote this. Why didn't I write 10 right there? If we're doing this, x plus 5 equals 7, what's the exponent on that x? 1, right? What's the coefficient in front of that x? 1. Why weren't they written? They're understood. There's certain things that don't have to be written because they are understood. In logarithms, there are certain bases that do not have to be written because they are understood. In logarithms, the most common base that we use doesn't have to be written because it's understood. What is that most common base? 10. It actually has a name. It's called the common log. So if you're doing a word problem or if we're talking in a conversation and I say something about the common log, you automatically know now that that is log base 10 without having to write the 10. This is the common log. Why do we call it the common log? Well, because that's its name, first of all, right? But it's the one that we use. That's the most common logarithm base that we'll use is log base 10. All right, what about the last one? Wait, do I just not know how to spell? What's that called? We've talked about it before, right? It's a natural log. There's no base written, but we know that every log has to have a base, right? So what's the base of the natural log? What number is associated with the natural log key on your calculator? What number is associated with the natural log key on your calculator? E. That's exactly right. Okay? So the way we rewrite this one is we say e to the 5th equals 148.413. Natural log. You can also write this, but if you do, I will probably make fun of you very quietly. Okay? Probably not, but you know what I'm saying. Okay? Log base e, we don't write log base e. What we write is natural log. Got it? Now, there's been confusion in the last couple of years about why natural log is ln. I think it's because this was French and it was really log en naturel. I really don't think that at all. I have no idea. That's how I say it in my brain though, so I remember what it is. Okay? If you want to think that too, that's great. If not, I don't care. Okay? So log base nothing we know is really base 10, and natural log is really log base e. Okay? So you have A through N on this worksheet to get done for homework. Any questions about any of these?